Hi, my name is Celia Kano, and I'm here today with Will Moon, Principal Naval Architect at Glosten. Thank you, Will, for being here.
Yeah, thank you for having me.
If you could just start by giving us a brief career overview and professional background, that would be awesome.
I started my professional career in the oil and gas industry after graduating from Virginia Tech in their ocean engineering program, and worked in the that industry for a few years, and then migrated to the Pacific Northwest and started working for Glosten. Been at Glosten for almost, well, over 20 years now, and yeah, have worked on all kinds of different vessels, tugboats, ferries, barges, research vessels, offshore floating wind turbines, you name it, I've probably worked on it. And done a lot of repairs and retrofits. And yeah, most recently spent 3 years in Spain overseeing the construction of the David Packard, which is why we're here today. So.
Yes, and I was wondering if you could talk a little bit specifically about, what you've done or what you did do with the David Packard research vessel.
Yeah. So my first role with the David Packard was project manager and design lead for the actual design of the vessel, which started really kind of the main focus of that started in 2018. And yeah, so we did a full kind of napkin sketch all the way through contract design package that was submitted to shipyards, bid, and the selected shipyard, Freire shipyard in Vigo, Spain, won. And then MBARI asked me to be the on-site owner's supervisor during the construction. So yeah, so then I spent 3 years involved in every little tiny aspect of the vessel, serving as MBARI's like on-site owner's representative.
Awesome. So I know that the David Packard has been in talks for a long time, dating back to inception with the Monterey Bay Aquarium Research Institute back in like 2010. So I was wondering if you talk about the timeline and development of the vessel from concept all the way to delivery.
Yeah. So yeah, in 2010, MBARI hired Glosten to really with the intent of replacing their now past research vessel, the Western Flyer. And that is an interesting vessel. It's called a swath, which is kind of a catamaran, but kind of a submarine. It's a called a sw small waterplane area twin hull vessel. Anyway, it's a unique kind of vessel. It performs some missions very well, and they were hesitant to move away from that. So our first work looked at three different vessel types, something that most owners don't even consider. They just say, well, we want a monohull or we want a catamaran. But we actually explored all three different types, did a lot of seakeeping analysis and kind of an evaluation. We did three different concept designs. And then at the end of that, the recommendation was that they go with a monohull design, and then things went quiet for many years, which is pretty typical for research vessel designs. They're complicated, they're expensive. People need to go find funding. So years later, in 2018, MBARI came back and said, "Okay, we have the money. Let's actually do the design now." And so that's when they hired Glosten to do that contract design package. Um, and yeah, and that led into all the other things that we've been doing. So
So I was wondering if you could just talk a little bit then about the collaborations themselves, especially since you were collaborating, MBARI and Glossen on the west coast of the US, and then you've got Ferrari all the way over in Europe. What were those collaborations like? And were there challenges with that? And if so, how did you tackle those?
yeah, I a project of this size to be successful requires lots of collaboration on many fronts, right? So um, I would say in addition to the MBARI and Glosten collaboration, which we had developed, kind of a mutual trust, we now kind of had to roll the shipyard into that broader team. And that was really my focus as an on-site owner supervisor was um, to, instead of making it a uh, kind of like owner versus shipyard confrontational situation, which can easily develop in those situations. I really worked hard to make us all one united team, and I think it was very successful. So any problem that came about, the focus was how do we work together here to solve this problem and give MBARI the best vessel possible. Of course, the shipyard has, their money at stake and interest, and so there's always balances and trade-offs there. But so obviously, our work with Friday Shipyard was super important to have a good working relationship there, and we did definitely. We also had DNV, Det Norske Veritas, which was the classification society, and they were yeah, they were instrumental in really delivering the vessel. They were there on site, maybe every other day for inspections. They had kind of more of a general purpose inspection and then also a specialist for electrical and automation and controls, which this vessel is very heavy on that side of it. So super helpful there. And then yeah, I guess speaking to like Glosten had people in Spain, in Seattle. Our electrical engineer was actually in Australia at that time. We had MBARI on the West Coast, and then we had vendors, ranging in that whole area as well. So we worked, I guess, yeah, we worked hard to make sure everybody had the right information, was informed about decisions, and yeah, a lot of time on the phone, a lot of time writing emails. But in the end, when you see the whole product kind of come together, and it operates and works efficiently, and for me, seeing the vision that I drew on that original napkin kind of come to life after a decade was super powerful and a wonderful experience.
Well, that's fantastic. I can only imagine, how emotional that must have been for it all to come together and then also to have such a wide range of collaborators and to have kind of that big, group effort there. If you could provide just an overview, of the specs of the vessel, just so we can kind of get an idea of what
Hmm.
it's like.
Yeah, so the vessel, well, it weighs about 1,200 tons. If you were to pick it up with a crane, you'd need something pretty massive. It's 50 meters or 165 feet long. It's 12.8 meters wide or 42 feet wide. And yeah, I guess one of the interesting things about the design of this vessel is that it was constrained by the harbor that MBARI operates out of, which is Moss Landing. They have a very shallow entrance into the harbor, and then their pier, sits a certain distance from the channel, and so the vessel was really constrained in length, in breadth, and in draft. And on top of that, MBARI wanted to have all of these capabilities in a modern research vessel. So it's pushing the limits of that confined box. But getting back to your question, it has a transit speed normally of around 10 knots. And then when it's doing the underwater mapping, its transit speed is around 8 knots for that. It can, of course, go a little faster, but its range is about 4,000 nautical miles, and it can stay out at sea for really kind of the design was for up to 3 weeks. Typical for MBARI is to stay out for a week or two with 18 scientists and a crew of 12. So uh, yeah, got 30 people on board eating and sleeping and living and working, and for about total of 3 weeks. Um, yeah, and then I think what makes this vessel unique and different is, MBARI doesn't do any fisheries research work. It's all, uh, I guess I would say most of it is deep sea oceanographic research. They're right near the Monterey, or the Moss Landing is right at the entrance to the Monterey Canyon. It gets extremely deep fast there. So they kind of right in their backyard, they have this amazing ecosystem that they explore. And one of the key parts of this vessel is that it's designed to launch and recover their 6-ton ROV, the remotely operated vehicle. And so a large part of the vessel is focused around that design.
That's fantastic. I mean, and it sounds, I mean, it sounds amazing. I can imagine in person. It's even more impressive. I'm just like picturing it in my head right now.
Yeah.
Um, and I was wondering if you could touch a little further on, the capabilities that you incorporated into the design that MBARI had specifically, asked for.
Yeah. So um their past vessel, the Western Flyer, could also launch and recover this ROV. But it really was very, very focused on just doing that mission. For this vessel, they knew that was going to stay as their core kind of operating missions, and it was going to drive the design of the vessel, but they also wanted to be able to launch and recover AUVs or autonomous underwater vehicles. They wanted to be able to do mooring deployments off of the stern a lot easier. They do a CTD, launch and recovery, for measuring the density and salinity of the water along the whole water column. Um, and so they wanted it. They wanted the core functionality of the ROV work, but they also wanted to be able to do other scientific, kind of more um, general purpose scientific work. And so that definitely drove some of the design. The ROV requires a very large hangar. It requires a winch below the main deck, which has 5,000 meters of about 1 inch diameter umbilical on it, and and then it requires a huge control room with a whole bank of monitors and a pilot, a co-pilot, a chief scientist all sit there and run it. So it's a huge operation and it's a huge investment into the capability of the vessel. And so that kind of it definitely drove the design. I would say like when you're designing a tugboat, you first figure out, okay, how big do the engines need to be to do whatever the project is, and then I wrap a boat around that. And in this case, it's okay, how big does this whole launch and recovery system and the winch and everything else need to be? Where does that need to go in the vessel? And then everything else gets kind of fit around that whole thing. So it really is kind of the central core of the vessel.
Yeah, that's so impressive. And again, it's just thinking about, how much effort and time went into designing it. I think that's really impressive.
Yeah, yeah, and it's it is an interesting part. I mean, the I pretty much worked on it from 2018 to 2024. Almost, there was a brief period in there where I wasn't working on it more than 50% of my time, but I've spent a large portion of time on one vessel for many years.
That's crazy.
Yeah.
I guess, and I wanted to, you've kind of already touched on this in a handful of different ways, so this might be a repetitive question, but given, the enormous size of the task, given MBARI's needs, and every, the collaboration, what was the biggest challenge you faced?
Hmm. Um, well, on top of trying to learn Spanish with my old brain, um, I think it was really kind of fitting in all of the capability that MBARI wanted into this very much constrained package. That was probably the biggest challenge. They really wanted, and I asked multiple times during the design. I asked their former director of marine operations, and I said, Mike, can I make this boat, 5 meters longer? Can I make it wider or deeper? And he's, no, 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 that's it. So at some point, yeah, you have to balance that capability. You also have to kind of know when to tell your client, I know you want all of this, but we can't have all of this and, fit it in this package because as boats get tighter and tighter, they get more and more expensive, and more difficult to construct. So I was there every day struggling with the shipyard, trying to figure out, okay, this one piece of equipment got larger than it was supposed to be. Now it doesn't fit, and now what? How do we deal with that? So it was yeah, it was a good experience for me to see, I get to see my mistakes firsthand, right? Get to learn them every day.
Yeah. Yeah, I mean, that's again fantastic. It's impressive, and just really cool. to
Yeah.
kind of hear about those things that we don't always think about when we're looking at the final product.
Yeah. Yeah. Thanks.
Yeah, and you mentioned briefly earlier, you mentioned autonomy. And so I want to really quickly
Hmm.
touch on maritime autonomy and autonomous vessels, right? They're just, hugely popular in terms of, solutions within the maritime industry.
Hmm.
And I was wondering if you could touch on how the David Packard, whether in design or in its mission or both, is set up to kind of support marine autonomy.
MBARI is certainly no stranger to autonomy and probably was a pioneer in a lot of ways with their autonomous underwater vehicles. They're getting close to a point where they can literally launch them, maybe not exactly from their pier, but almost from their pier and then have them come back in a couple weeks with data and having completed their mission. So they're getting more and more advanced. I believe MBARI is designed, built, patented, uh, and actually shared a lot of that kind of open source design too with the broader uh, oceanographic community. So yeah, so they're no stranger to that. But when it comes to the vessel, um, I would say the vessel design itself doesn't have a lot of autonomy, but more efficiencies to uh, make it easier to operate with a smaller crew. So the captain is usually on the bridge of the vessel, um, you know, running the whole vessel themselves. And there isn't a large crew associated with this vessel, so there is a lot more automation, connectivity, um, lots of CCTV cameras to make sure you can see what's going on at any given time. Um, and yeah, and with that comes a lot of cybersecurity challenges. So this was actually the first vessel that DNV uh, gave a cybersecurity notation to in Europe. And so it has a cybersecurity notation and an approval plan and we spent lots of times going over all the details of how every piece of software is connected. Even just as an example, a piece of equipment that that is connected to an internet source that every once in a while the vendor wants you to download new software for is a threat, right? So in a lot of cases, disconnecting some of that was the solution. Um, uh, yeah, so it's definitely a challenge, but kind of protects their asset from attacks.
Awesome. And then last question is just, talking a little bit about the vessel since it was delivered. Um, if you can share if you know what the vessel has been up to since then, and if is there anything that we can look forward to with the vessel?
Since its delivery, we unfortunately we had some major equipment failures. So all three alternators right before, I mean, I think it was about a week before MBARI was departing from Spain, they had a failure in one of their alternators. It was removed, sent to the factory for testing. And unfortunately, the manufacturer determined that all three alternators were bad, had to be replaced. So we waited for months while the new equipment was manufactured and then reinstalled. So we definitely got a late start. And we've had some other teething challenges with, a new complicated vessel with a lot of interconnectivity. Um, and so it's we haven't gotten to do all of the science that we were hoping to do at the beginning, but they are getting out and doing really good underwater mapping. This vessel has very large transducer arrays on the bottom, so they can map the ocean bottom. They can communicate with their autonomous vehicles or their ROV. And that system is proving that combined with the hull form is proving to be extremely successful. So they're having really great success there, and they're slowly getting up to speed with using their ROV. So it's I think there'll be wonderful things to come in the months, years ahead. But I'll let Ambari speak to the specifics there.
Yeah, awesome. Well, thank you. I mean, we'll definitely keep an eye on Mbari, but it's great to hear from you and from the Glossen side of things. So thank you so much for
Yeah,
taking the time today.
yeah. Thank you. Appreciate the opportunity.